Imagine a dead planet, silent, covered in rust-colored dust, scorched by cosmic cold, stripped of air and life. This is how we've always pictured Mars, a distant red sphere, frozen in eternal silence. But what if that silence is deceiving us? What if deep beneath the surface, in impenetrable stone depths, something is moving? Mars has always fired the human imagination. Long before the first probes ever left Earth, people gazed at that red dot in the night sky and asked themselves, are we alone? Is there anything alive out there, beyond those millions of kilometers of emptiness? For a long time, the answer seemed brutal and unambiguous. No, Mars is dead. Mars is empty. Mars is just a rock in space, slightly larger than our moon, wrapped in an atmosphere so thin that any earthly organism would suffocate within seconds. But then the data came in, and everything changed. In 2018, a spacecraft descended onto the Martian surface, one destined to overturn everything we thought we knew about this planet. Its name was InSight. It was the first Martian seismograph in history, an instrument built not to photograph landscapes or drill into the ground, but to listen to the planet itself, to detect its inner trembling, its whisper rising from depths unreachable by any camera or drill. And Mars began to speak. The first marsquakes were recorded as early as 2019. At first, scientists didn't treat them as sensational. Planets shake, that's normal. But the longer InSight listened, the stranger the picture became. Signals were arriving from places no one expected. They had characteristics that didn't fit conventional geological models. Some vibrations lasted for hours. Others appeared with an unsettling regularity, almost like a heartbeat. And that very word, heartbeat, began appearing more and more frequently in scientific discussions, though researchers used it with great caution. To understand why this data stirred the scientific world so deeply, we need to take a step back and recall what we know about Mars and what we still don't. 4.5 billion years ago, both our planets were in roughly the same position, a young Earth and a young Mars, both blanketed in volcanoes, both with liquid water, both, in all likelihood, holding conditions under which life could have arisen. But then their fates diverged. Earth held on to its magnetic field, kept its atmosphere, stayed alive in the most literal sense. Mars lost everything. Its magnetic field faded. Its atmosphere was stripped away by the solar wind. Its water vanished, partly evaporating into space, partly freezing beneath the surface, and the planet, it seemed, died. Seemed, because the interior of Mars still holds heat. Not as much as Earth's, but it's there. And it's precisely that heat which gives rise to a question that keeps planetary scientists up at night. Could there still be active geological processes deep within? And perhaps, and this is a truly audacious thought, though a scientifically serious one, could there be conditions down there under which simple microorganisms might survive? InSight's data added a new dimension to that question. The seismograph recorded more than 1,300 seismic events over the course of its mission. Most were small and faint, but among them, several extraordinary cases stood out, ones that made scientists literally stop everything else. In 2021, 2 major marsquakes were registered, each with a magnitude of around 5. By Martian standards, a colossal force. These events gave scientists the ability to peer into the deepest layers of the planet, much like an ultrasound allows a doctor to see inside the human body. And here is what they found. The core of Mars turned out to be liquid, not a solid iron ball, as some models had predicted, but liquid, a molten metallic sea at the very center of the planet. Its diameter is approximately 1,800 kilometers. This discovery alone was staggering. It meant Mars had not fully cooled. It meant that deep within, an inner fire still smoldered, heat inherited from the very birth of the solar system. But a liquid core is only the beginning of the story. What drew researchers' attention next was the nature of the seismic waves themselves. On Earth, when an earthquake occurs, waves travel through rock in predictable ways. We know how they behave in different layers, through the crust, the mantle, the core. We can read our planet's structure through those waves like a book. On Mars, InSight began doing the same, and some pages of that book turned out to be unexpected. Certain signals traveled differently than they should have through a completely solid and uniform mantle. This could point to the presence of molten or partially molten zones within the Martian mantle, meaning magma there had not entirely solidified. Moreover, in 2022, a seismic signal was recorded, whose source could be approximately pinpointed. It pointed toward a region known as Elysium Planitia, a place that had long attracted scientific interest. Elysium Planitia is not simply a beautiful name with echoes of ancient mythology. It is one of the few regions on Mars where volcanic activity may have occurred relatively recently. In geological terms, of course, some of the lava fields there are so young that researchers date them to just a few tens of millions of years ago. By Earth standards, that sounds like an eternity. But geologically speaking, that is practically yesterday. And it was from beneath this very region that the mysterious signal originated. What exactly produced it? This is where the real scientific detective story begins. One hypothesis involves so-called tectonic movements caused by the cooling and contraction of rock. Mars does not have plate tectonics in the way Earth does. There are no drifting continents, no subduction zones, but the crust can still crack, deform, and shift under the influence of internal pressure. This would explain many of the recorded vibrations. But there is another hypothesis, more captivating, and yet entirely serious in scientific terms. Some researchers point out that certain signals recorded by InSight share characteristics with what are known as cryovolcanic events. Cryovolcanism occurs when, instead of molten lava, a mixture of water, ice, and gases erupts from beneath the surface. Such phenomena are well known on other bodies in the solar system. For example, on Enceladus, a moon of Saturn, or on Europa, one of Jupiter's moons. But Mars? No one had anticipated that. If reservoirs of liquid water or slushy water-ice mixtures truly exist beneath the surface of Mars, and if the pressure inside these reservoirs periodically reaches critical levels, they could produce exactly these kinds of signals. Not explosions, not earthquakes in the conventional sense, but something in between. Deep sighs from a planet that has not yet accepted its fate. Water. That is the key word in this story. Water on Mars is not science fiction, and it is not wishful thinking. It is a scientifically confirmed fact. Radar measurements taken by the European probe Mars Express back in 2018 detected a signal beneath the southern polar ice cap that is interpreted as a liquid lake. Its depth, by various estimates, is several meters and possibly considerably more. It lies approximately 1.5 kilometers beneath a layer of ice and dust. That discovery alone caused a sensation, but more importantly, it demonstrated something fundamental. Liquid water on Mars is possible under the right conditions of pressure, and with sufficient salt content to lower the freezing point, water can remain liquid even at Martian temperatures, which average around -60 degrees Celsius. And where there is liquid water on Earth, life is everywhere. At the vents of deep-sea volcanoes, in the boiling geysers of Yellowstone, in acid lakes, and in the frozen wastelands of Antarctica, life is remarkably resourceful. And that is precisely why the question of Martian water is not merely a geological question. It is a question about the possibility of life existing right now, at this very moment, while you are watching this video. To be honest, of course, there is no direct evidence of biological activity on Mars. InSight did not find bacteria. The rovers have not discovered anything that unambiguously points to living organisms. But here is the paradox. We have found no definitive disproof either. Life, if it exists there, is hiding deep. Deeper than current instruments can reach. And the signals that InSight recorded make us wonder, is what we are hearing simply the voice of dead stone, or could it be something more? In 2022, the InSight mission came to an end. The spacecraft's solar panels had accumulated so much dust that it simply could no longer receive enough energy to function. It fell silent. But the data it managed to transmit will keep scientists busy for many years to come. And already, those findings are fundamentally reshaping our understanding of Mars. Meanwhile, other missions continue gathering pieces of this extraordinary puzzle. The rover Perseverance, operating inside Jezero Crater, a place where a lake once existed, is collecting rock samples that are eventually planned to be brought back to Earth. Among those samples may be traces of ancient life. Not life from today, but life from billions of years ago, when Mars was warm and wet. That alone would be the discovery of the century. But the data on deep subsurface vibrations adds yet another layer of questions. If the planet is geologically active, then it is generating heat. If it is generating heat, then hydrothermal zones may exist beneath the surface. And hydrothermal zones, as we know from Earth, are true oases of life, thriving far from sunlight, powered entirely by the chemical energy of minerals and water. Strange creatures live there. Blind shrimp, giant tube worms, bacteria for which a boiling sulfur solution is simply home. Could similar ecosystems exist in the depths of Mars right now? Most scientists will tell you, unlikely, but it cannot be ruled out. And that phrase, cannot be ruled out, rings louder than any confident affirmation, because just 20 years ago, the very idea of liquid water beneath the Martian surface seemed like fantasy. Then it turned out to be real. The next major step in exploring Mars involves new seismic missions. NASA and the European Space Agency are discussing the possibility of deploying an entire network of seismographs at different locations across the planet. A single instrument, like InSight, can detect vibrations, but cannot always pinpoint their source precisely. A network of 3, 4, or 5 seismographs would allow scientists to triangulate sources with accuracy down to a few kilometers. It would be like going from a single microphone in a vast dark room to a fully equipped recording studio. Such a network could definitively answer the question, are there active volcanic processes on Mars? Do subsurface bodies of water exist? And most importantly, could these vibrations have a biogenic origin? Meaning, could they be connected to the activity of living organisms? That last possibility sounds like science fiction. But remember, every great discovery once sounded exactly like that. There is one more remarkable aspect of this story that rarely gets mentioned in the context of Mars research. Studying the interior of Mars is not just science for the sake of science. It is also preparation for future crewed missions. If humans ever travel to Mars, and plans for this exist, not only among private companies but within space agencies as well, they will need to know how geologically stable the ground beneath their feet will be. Is there a risk of marsquakes? Could sinkholes suddenly open beneath the surface? Where is it safe to build a base, and where is it not? The seismic data from InSight is not merely academic information. It is a survival map for future Mars explorers. And in that sense, the small three-legged lander that stood quietly on a Martian plain, listening to the planet, is one of the most important steps ever taken toward the day when a human being will set foot on Martian soil. But let us return to the central question. Is Mars alive? What do its depths conceal? The answer science gives us today sounds like this. Mars is not entirely dead. It exists in a state that might be called deep sleep. A geological slowdown in which internal processes continue, but incomparably more slowly than on Earth. Its heart, a liquid core, still beats. Its mantle may still harbor pockets of heat and melt. Beneath its surface, water almost certainly exists, locked in ice, dissolved in salts, sheltered from the merciless Martian cold and radiation. This planet survived a catastrophe. It lost its magnetic field, was stripped of its atmosphere, and surrendered its oceans. But it did not give up entirely, and it is precisely that refusal to surrender, that stubborn, barely audible pulse in the depths of a red world, that compels us to keep listening, keep exploring, keep asking questions. The universe does not offer simple answers. It never lays all its cards on the table at once. It beckons, hints, astonishes, and every time we think we've understood something for certain, it shows us a new horizon, behind which even greater mysteries are waiting. Mars is one such horizon, red, distant, silent on the surface, and full of whispers within. Perhaps we are searching for life where there is none. Perhaps we are hearing the voice of cooling stone and mistaking it for something greater. But perhaps, and this is the possibility worth everything, we are standing on the threshold of the greatest discovery in human history, a discovery that will forever change our place in the universe and our answer to the oldest question of all: are we alone? If this video made you stop and think, if it added even a little of that sense of wonder at the universe that we work so hard to bring you, please leave a like. It's a small gesture, but it means the world to us. And write in the comments what you think. Do you believe life could exist on Mars? Even something microscopic, something barely alive? We genuinely want to know. Stay with us, and until next time.